So today we're going to be talking a little bit about optimizing risk and doing synthetic scenarios. We've got an amazing presentation for you today from Louise Kaufman. And before I get into too much detail and spoil too much, I'm going to pass it on to Louise, and he's going to get us started today with an amazing super demo. Thank you.
Thank you, guys. Everybody can hear me? Yes? Okay. Guys, so in order to start my super demo, I want to actually explain what problem I'm trying to solve here. So basically, a very common problem that is how much we should charge for interest rates. So what is exactly the pricing or the right pricing, and considering risk factors. And also now, since everyone is talking about Gen AI, does Gen AI can help us to do that? So I wanted to show an alternative way to use our Gen AI platform to actually improve the risk-based pricing, okay? This process, we have a combination of 3 solutions. I don't know if you guys heard about before. So we have this new solution, SAS Data Maker, that we will be showing here during the whole SAS Innovate. I will be using the SAS Risk Engine, which is an engine that I use to combine many machine learning models, risk models, or many data coming from solutions like DataMaker. At the end, I'm gonna use SAS Intelligent Decisioning to automate the whole lending decision flow. Well, I want to highlight one thing. So why I'm calling synthetical data Gen AI? Because actually it's part of Gen AI. So I'm not sure if it's clear. This is the approach we use here at SAS. Nowadays, you guys gonna see many of us talking about agentic AI for many other use cases, but today I'm gonna use the synthetical data solution that is the SAS Data Maker. But I mean, I'm not sure how many people here are familiar with synthetic data generation using GAN, okay, Generative Adversarial Network. So basically, GAN is one of the algorithms we have embedded to SAS Data Maker. So just to have a high-level overview. So basically, for GAN, we have like one network, one machine learning model that picks real data, okay, real data samples. But we do have a generator that generates random data. But we do have another component, another network, that tries to classify how close this synthetical data is to the real data. So this is a looping process. This is part of our SAS Data Maker. But since everything in SAS, we do have a library, so I can open in the library and add more components. So I basically customize this algorithm we have as part of SAS Data Maker using a RNN algorithm. So what I do, so basically on top of the real data, I use the RNN to actually model the time structure. So in our case here, I'm trying to solve a lending optimization pricing, okay? So I'm gonna go and use all the risk factors that they impact the lending process, and I will try to model all of them using the RNN. But not only that, what do I do after I do this model? I basically use this in our generator network, because every synthetical data needs to follow this time structure. So basically, I added 2 layers in our GAN algorithm. This is becoming a little bit more popular nowadays. I don't know if you guys heard about time GAN. And we can use that combining Data Maker with the visual forecasting library that we have at SAS Viya. Well, in order to, this is not a Data Maker demo, but I want to just explain how Data Maker works in the UI. So basically, in Data Maker, we can create a new project. And when we are creating a new project, we basically can select any data set. So for example, I have 2 risk factor data sets, and selecting those, I can select the algorithm. So this algorithm will actually create the synthetical data for me. And well, once I have the data created, I can actually use this as one of my inputs. So what did I do in this demo? I actually picked the output here that you guys see here, and I add that time series component. Well, there are many moving parts. It's hard. You guys are welcome to go in my booth here in the financial services. I can show deeper. But the second thing that maybe will be a question, I don't know how many of you work in the credit risk management, how I will be incorporating the risk factors. So I have a synthetical risk factors, and I do have a probability of default model. How I will be incorporating the synthetical data factors in my probability of default algorithm. I'm going to use this methodology, I don't know if you ever heard, that I'm going to use the intercept of the logistic regression, and I'm going to change for the time series that came from the data maker. So all the SAS data maker outputs, they're going to feed my existing probability of default. This is one of the options. We can do other options, but this is, I implemented this a few times. It works very great. And having the model, the PD model, I have the other models as well, but now I need to use this model to simulate many scenarios, many paths. So basically, I'm going to use the SAS Risk Engine. This will be part of my demo. I'm going to open this and show it to you, but I think it's easier to show the slides to help you follow me. So basically, in SAS Risk Engine, for every factor that I simulated in the data maker, I'm going to generate many paths. Not only these paths, but I also can simulate many scenarios for my risk factors that I did on data maker. So this is the kind of data set that I'm doing, but what is the challenge of doing that? If we have to code this in SAS, Python, or R, it means that we have to do many loopings, okay? And not only that, the bigger is your portfolio, more complex will be the calculation. So I don't know how many of you have heard about Risk Engine. In Risk Engine, we can actually get rid of all the looping process and just point the models, the portfolio, and ask to Risk Engine to solve all the looping, okay? And I'm going to show the SAS Risk Engine. This will be part of my demo, but we can do many more stuff, not only risk-based pricing, but we can do PFE, CVA, sensitivity analysis, so many calculations. Well, as I say, the idea of these slides is just to explain all the moving parts in my demo, so it will be easier to digest. So again, what is my flow? I started a data maker. I use the risk factors that I use unemployment rate, GDP, and basically I did a time gun in customizing the data maker outputs, and now I have almost like 36 scenarios of my risk factors. Having the scenarios, now I'm going to use this as an input in the risk engine. In the risk engine, I'm going to calculate the credit value at risk. Why? Because this is one of the inputs of my risk-based pricing algorithm. Having that, I'm going to actually implement this algorithm on SAS Intelligent Decision. And SAS Intelligent Decision is basically our decision engine that we are using and helping customers to implement real-time and near real-time decision flows, okay? So the idea of this is to explain the flow so it gets easier to you follow me when I'm moving to the demo. So I'm gonna go and access the environment. So let me start here just to show my inputs here. So basically this one, the first one that you guys are seeing, are I have basically on GDP, all the risk factors I had. I created principal components that I call RFR1 and RFI2. So basically, these two are principal components on all the economic data I had. And I asked the data maker to generate almost like 36 replications and 36 forecasts using the RNN algorithm. Not only that, I do have my portfolio data. So it's a very simple one. This could be complex. So basically, I do have my portfolio that I have. Every row here is a loan, okay? I do have the unpayment balance. I do have the income of the owner of the loan. the inst type, and I do have more other informations as well. But let's be simple here. So having all those components, how do I create the whole evaluation process to use Risk Engine to calculate the credit value at risk? So now I'm going to switch to the Risk Engine. Risk Engine is part of VIA platform, so basically if I click on the left side and I click here on the Risk Engine, you'll be going to this interface. In the Risk Engine, we have many possibilities, many options here. So I can create a pipeline, I can create model groups, I can create risk methods. That could be Python or SAS, but let's focus on the problem that I'm trying to solve. So for our problem here, I'm going to start a new pipeline. Let's call Super Demo. Pipeline. Let's call like that. Well, I will be using the default configurations. So in the pipeline here, I have some options. So I do have the portfolio data, the data that I have my loans. I do have the market data, and I want to actually calculate my risk measures on top of the risk factors. And these guys, they came from DataMaker. So let me do that. So for the portfolio data, we have many options. We can use mitigation data, counterparty data, but we are being simple here. So I'm going to select that portfolio data that you just saw here before. It was called Super Demo Portfolio. For the market data, I'm going to use a current screenshot from my economic data. That I won't be using that for now, but this I will be using the information that is coming from the SAS DataMaker. So let me just here. I think it timed out the connection here. Let me just. Okay. So here, guys, the solution, the Risk Engine, have many options. The traditional methods are here. So if you guys want to use Delta Normal, Monte Carlo simulation, here I'm going to use user-defined. So user-defined means I did the simulation before the Risk Engine. So now I'm going to get the information that it comes from DataMaker. So all the risk factors that I mentioned to you, they are here. Okay. So I do have all of them. Okay, so using the simulated risk factor, what type of calculation I will be doing? For this demo, I'm going to evaluate my portfolio. Okay, we have other options here, but I'm going to calculate the credit value at risk. So in the evaluate portfolio, I do have to select something that we call basically a schema. We have to select evaluation map here. So basically, when I click here, what is a map? Map is the evaluation logic. So I'm gonna pause here and I'm going to show where are them. So basically, if I go here, model groups, let me just save first. So let me go to model groups. And I did it before, so I do have this evaluation initial. So if you guys remember all the loopings I mentioned before, so basically what do I have? I have ECL calculated on top of the models I have. And as you guys can see here, I have the expected credit losses. So basic cases means I am calculating the expected loss for today's dates. But if you remember, my risk factor data set has future forecasts. So on below here, I'm telling Risk Engine, do the same calculation. It could be different for the horizon that I'm forecasting my portfolio value. So I can do that. And here on the side, I can pick the model. So for example, imagine that I want to select another model. So I can add models here, and I can search for many models. So there are many options here. So basically, I already imported one of the models, this PD model, for example. And basically, this PD is the probability of default model that I explained in my slides, and the LGD model. And for exposure default, I'm just using the unpayment balance, okay? So having this evaluation ECL as a group, I can come back to my pipeline here, And I can select, if I come back to evaluate the portfolio, I can select this, something that I call demo map, okay? And this demo map, if I come back to the map here, sorry, because I forgot to show you that. So the risk method map, let me double click, is the evaluation ECL. That logic that I showed before, the expected credit losses, I am saying, okay, for all the instruments that I have in this portfolio, use these methods. But imagine if you have in the same portfolio different loans, different models, you can start to combine different segments using different algorithms. But again, I'm trying to be simple here. I'm going to use this demo map. So if I come back to the pipeline here, that is what I'm doing. So I'm here selecting the demo map. That is calculating for every horizon forecasted in a data maker my losses, okay? And this will cover all the horizons. So how do I say, hey, calculate this to all the simulated risk factors? So if I come back here on the risk factors, I can say how many months I will be forecasting. I will say 36 months. And if I close here, and how many replications I have coming from data maker. I knew this before, it was one of the parameters, so I did 36. Not only that, we have to select what is the granularity. Here I'm using a monthly granularity. And once I do this calculation, I need to save this in some place. There are people, they like to stay here. I like to send all this calculation to Visual Analytics. So I'm going to do that, so I'm gonna create a new environment. And I'm gonna save here, and I'm gonna run this pipeline. If I hit this run, I basically will generate all these outputs. I did this before the presentation, of course. So here, if you guys see on the left side here on VA, I do have the data maker output, but let me show you guys the output that came from the risk engine. So for all loans, for all first loan, all the loans, I do have in the independent credit value to risk. So this is the marginal credit value to risk calculated in the risk engine before for every loan. I do have other information like unpayment balance, loss given default. And if I combine this and generate the aggregation view, so for example, if I want to see, okay, what is my loss distribution combining those scenarios in data maker with the risk engine. And I can actually switch, because if you remember, I have more replications, so I want to show for the replication number 8, for the replication number 2, they are similar, or for all the replications taken into account. But now, I just solved one of the problems in my business challenge. I only have the credit value to risk for every loan. How do I make this a model in production for a new lending process? So basically what do I do is, I'm gonna switch to this window here. And what do? I can do this on the fly, I think it's good. So imagine that I want to take this data, okay? And this data is actually this one that came from Risk Engine. And instead of I want to create a real-time model. So basically what I'm going to do is a surrogate model. So I'm going to, let me choose one approach here. Let me go with gradient boosting, for example. So why I'm doing that? Because I want to create a real-time scoring process to calculate the marginal credit value at risk. So basically, I want to take the calculated credit value at risk in the risk engine as a response variable, and I want to use the data, especially the ECL, to calculate a prediction to the individual credit value at risk. Why I'm doing that? Because imagine that for every portfolio evaluation, I need to pick the whole portfolio, even for a new loan, and I need to rerun all the portfolio calculations. But if I can do a proxy using a machine learning model, so I'm using the gradient boosting to mimic the portfolio calculation because I want to apply this to a new loan. The new loan is not in the portfolio already. So and guys, you can see here in this model, how accurate is this? So the yellow line is the one that I use on the risk engine, and the blue line is the one that I calculated here using this surrogate model. Okay, so I want to use this as part of my new loan origination process. So I can hit these three buttons here. I can basically use this register model. So let's call this real time CVAR model. So once I do that, SAS will be automating the value at risk for every loan as a real-time model. So once I do that, once I complete, I can call this in our intelligent decisioning solution. So now I'm going to move to the intelligent decisioning solution. Not sure if you guys are familiar with that. So this is a solution that we can combine. Let me zoom in here. All the tasks that are part of a loan origination process. So here I combine identity detection for fraud, and here I combine the credit risk, the application fraud, and even other like rating classification. So before I include my CVAR here, I'm going to create something from scratch. So let me switch for this one. This is the risk-based pricing calculation. So if I double click here, you guys will see that I'm doing something very simple, okay? Of course, the real hierarchy is much more complex. So I'm using the interest rate that maybe your policies will suggest, minus the ACL that I calculated with the models, minus operational costs, divided by the UCL that came from Risk Engine. So I do have the logic already, but now I need to include that model. Sorry, I need to include the model that I was showing to you. So let me just go for let me close this one, and let me include the model that I just published. So if you remember the model name, so I'm going to include the model that I just did. So basically, if I go in, and the model was called, let me see. Demo, let me see here. Just need to remember the name of the model that I did. It was, I don't remember the name. Let me see. Real-time CVAR. And this is the model. So now, this is the model that is coming from the Risk Engine to calculate the CVAR for every loan. And now I have the hierarchy calculation here. I can remap the variables. So this variable is coming from the Risk Engine. The interest rate is coming from the user interface that will trigger the decision flow. And what I can do before putting this in production, I can do a simulation here. So let me just do something like so. I'm going to simulate this model in the real time, remapping the variables. I already did this for the presentation, so I'm mapping the variable. And let me run this, because before promoting this flow in production, I want to see how the hierarchy will look like. So let me just reopen here. It was calculated, it was too fast. So here I have the hierarchy calculated. So having the hierarchy calculated here, I can explore, I can do optimization logic using VIA. And let's suppose I'm good, I have everything I needed. So I can even use the risk-based pricing flow, and I can publish in production. So here on the right side, I can validate the flow, and I can actually publish this in production. So what is publishing means? I'm creating a microservice that will call this for every new flow, will call this whole hierarchy in real time using syntactical data, using the Risk Engine calculation, and for every new loan, you guys will have a new hierarchy. And again, you guys can use this process to keep actually improving your forecasting, but also your risk calculation. So I want to finish just here on the flow, just to see, to actually make more clear. So what I did before, so I was here, let me just use I got all the risk factor simulation, calculated the individual value at risk using Risk Engine, and deploy this as a real-time model in my loan origination process. And sorry, there are many moving parts here. I will be happy to actually invite you to go in my booth, and I can show and answer any details. Let me pause here to see if you guys have any questions. I'm sure you guys have, but you can also ask them after, okay?
Yeah, feel free to raise your hand. I'll bring over the mic if you have any questions, and we can get moving. All right. Well, if we don't have any questions, feel free to reach out to Luis at his booth. Otherwise, thank you so much for attending. Let's give it up for Luis one more time.
Thank you.
Thank you for the amazing presentation.